Welcome, ladies and gentlemen, to your next video, kind of talking about the idea of building circuits. So this is going to be our first kind of hands-on lab, as much hands-on as you can be when you are socially isolating, in terms of building circuits and kind of seeing how we can kind of harness electricity and get it moving the way we want to get it moving. All right, so the first thing that I need you to do is, hopefully you've opened up this Google Doc. Go to the link that says Online Circuit Builder Kit. Okay, so you're going to click that. It should open up a FET simulation. When it asks you intro or lab, click intro. And what should happen is it should open up a screen that looks something like this. All right. And right now, if you look to the left side, you'll notice you have 5 things that you can play around with in our toolbox. For this lab in particular, we're only going to use 4 of them, so we are not going to use the resistor. All right. Now, this lab kind of can mean different things for different people. If you have worked with circuits before, especially if you've been kind of working with them in engineering, you'll be looking at this piece. This is probably pretty familiar. If you've never played with circuits before, that's all totally awesome. Some of these pieces might seem kind of strange at first, but I promise we're just going to play around with the basics right now. Just kind of understand exactly how it is to build a circuit. All right, so our notes are going to, or this video is only going to cover the first section. All right, after that, we are going to a second video that covers the second part of these notes. So hopefully you've opened up the circuit construction kit. The first thing that I want you to do is you're going to grab some wires and a light bulb, because our task when we do this is that we are going to create a circuit where basically we light up a light bulb. Okay, now if you know how to do that already, that's awesome. I still kind of want you to go in the order just that you can understand exactly what's going on. But if you don't know how to do it, that's even better, because we're going to find out today. So the first thing I want you to do is grab some wires and a light bulb. So you're on your circuit construction kit. You're picking up some of these wires, maybe a light bulb. All right, you'll see all these little circles. Basically, what you need to do is connect them all, and that will kind of set them up. So basically, set them up in such a way that they are all connected. So I'll give you a couple seconds to do that. All right. Now, our first question is, if you hook all these up so that they are connected and they kind of make one continuous path, all right, what seems to happen to the light bulb? And if we do that right here, if we were done it in your lab, interesting, you'll notice nothing's happening. All right. Now, what we're seeing is that these little symbols right here, these all represent electrons in the wire, and right now they're just kind of sitting still. They're not doing anything. So the light bulb is not lighting up, and it's not really doing anything interesting for us. So we probably need to do something to kind of set this up so that the light bulb will move, because maybe we need to do something to get the electrons moving. All right. So our next question is exactly that. What piece of equipment will we probably need to get the electrons in the wire moving? All right. And then, unfortunately, you can't really answer me. You're welcome to yell at your computer screen. Let everybody know. Maybe I'll hear it from far away. But if you said battery, you are correct. And we're no longer talking about physics, it sounds like. Now we're on Dora the Explorer. So if you said battery, you are indeed correct. So what you can do is basically click a little joint, cut the wires up, and grab a battery. Okay? Now, interesting. All right, I set it up so I've now put my battery in this circuit, and now all of a sudden the electrons that weren't moving anymore are now starting to move. All right, and of course what this means now is they're moving through the light bulb, and it seems to be producing light. Okay, and congratulations, what you have just done is, for the first time, you have created a circuit. All right, and what you've done is you have created electricity, and it is now moving through your circuit and being used in a way that is useful to us. All right, now, just to kind of, what I want to experiment with is try it out. Flip the battery around. All right, because I promise it doesn't really necessarily mean, it doesn't really matter which way you put the battery. So you can put it like I did, or you can put it the other way. All right, and it does seem to kind of, there's one thing it does seem to affect, but I'll let you kind of figure it out. I'm not going to tell you everything. But in both cases, it doesn't seem to really matter which way I put the battery. It's still causing these electrons to move. All right, so right there, we've started by looking at 2 pieces. Our circuit needs to be kind of, well, let's see. Our circuit needs to have a couple things in it. All right. Now, what we want to do here is, let's just see real quick what happens when I cut apart one of the wires. So let's say I decide I don't really like this wire touching this light bulb. It doesn't go with the aesthetic of this whole lab, so I want to get rid of it. So I cut it. Well, even though now I have a battery in this circuit, unfortunately, it doesn't seem like anything's flowing anymore. All right. But as soon as I connect it, and maybe I'll add another piece of wire and I connect it, all of a sudden it goes back to now everything's moving again. All right. And that's a fundamental rule about circuits, is that circuits have to be they have to be closed, as we call them, which means there needs to be a complete path for the electrons to travel in. All right. And if a circuit is not closed, it's referred to as an open circuit, which means that electrons can't flow, so electricity cannot move through this. All right. So reconnect it. We're now up to the part where it basically says, so we need electrons while we're moving. We said the piece of equipment was a battery. Once we put the battery in there, the electrons did begin to move, which means we had electricity, and it's causing the light bulb to light up. Now, for the intents and purposes of a circuit, a battery can basically be thought of as an engine that moves electrons. Okay? What happens in a battery is that basically, depending on what type of battery it is, it creates a charge difference between the sides of the battery. All right, and we're going to go much more detail this in the next video, so I'm not going to really go too much into it, but basically, it creates a charge difference, which basically forces the electrons to start moving through the circuit. All right, so it drives them forward. Now, as soon as you take that battery out, the engine for the electrons is gone, which means as soon as I cut that out, the electrons no longer can move through the circuit. Now, we already answered this question earlier, but if I cut the wire so there's a gap, does the light bulb stay lit? We already said it did not, because now the circuit is open and not closed. And in all these cases, when I'm going through these notes, feel free to stop at any time and write into your note sheet. All right, I know I'm not doing it right now, but that's because time is of the essence when I'm making these videos. So I trust that you'll pause when you need to and write down your notes. Okay? Now, we get to the point where we're trying to see there's basically at least three things you need to have a successful circuit. So we started by understanding the idea that we probably need a battery in it. All right. We probably need it to be complete. Now, let's say I take out my light bulb. All right. So let's say I don't really want it in there. And let's reconnect everything so that now I have a battery and these wires. Interesting. All right. Now, what we can notice right away is that the electrons are moving way faster than they were before. And unfortunately, it seems like we have created kind of a little bit of a fire hazard. In fact, we've set our battery on fire. All right. Now, that is kind of a problem because according to our rules of circuits, all right, we kind of have fulfilled the things a circuit needs. It's a complete circuit, and it has a battery in it. It has something that kind of moves the electrons through it. But what we're finding out is that in order to have a safe circuit, you need something that uses the electrons to do something. All right, we refer to that, it's the load in the circuit. All right, and in this case, the load is going to be in this light bulb, because what the light bulb does is it takes the electrons and it kind of takes their energy and it uses that energy to light up the light bulb. All right, and what that means is that, and we'll go into much more detail in this with the next set of notes, is that basically there has to be something using the energy of the electrons. If this light bulb's gone, the electrons kind of just keep moving through the circuit, and what happens is basically they keep getting pushed faster and faster and faster through the circuit until eventually the only thing they can dump their energy into is the battery. And as we can clearly see from the simulation, when we do that, we set it on fire. All right, this is what's known as a short circuit, because what we've done is create a path of least resistance. And once again, we're going to talk about that in more detail on the next video with the next set of notes. All right, so the last thing I want you to do is I want you to put the light bulb back in and then set up your circuits that have the option of turning it off and on at will. So this is one where I want you to kind of experiment, play around with it a little bit, play around with the things over here, pause the video, and try and set it up so that you can create a circuit where you can turn it off and on at will. All right, so I don't know, take about 2.5 to 3 minutes, play around with this a little bit, pause the video, come back when you're ready. Awesome. All right, so hopefully what you did is you put your light bulb into the circuit. All right, and now I've created it so now it's turned on, but I really want to set it up so that I can turn it on and off at will. And unfortunately, the only way I can do that And the way I've set it up is to literally cut a piece of it in half, which is kind of would not be very feasible if I'm trying to turn off a light every time I'm in my house. I cut wires. So instead, hopefully you look to the side and you say, the word switch, that sounds interesting. And you hooked it up. Now, originally when you set this up, the switch is switch is open, which means that the circuit, you'll notice, is open because it's not a complete path. But if I close the switch, what I've done now is I've created a completely closed circuit, which means now the electrons can flow through it. And if I want to turn it off, I just open the switch, turn it back on, close the switch. All right. So we're starting to see this idea that when you are playing around, when you flip a switch at your house, you're pretty much opening or closing a circuit depending on what you're asking it to do. All right. So with that being said, let's talk about the 3 things that you might need, it seems like, to build your circuit. All right. So hopefully, kind of looking around and playing around with these circuits, there were 3 things we kind of needed at minimum to make sure we had a successful circuit. All right. The first was arguably the most important, and that was the circuit needed to be complete. All right. And that means it needs to basically be one closed path so the electrons can flow through it. So that's the first thing it needs. The second thing it probably needs is it needs a battery or something, because we might find out it's not always going to be a battery, that drives the electrons forward. Or just say drives the electrons in the circuit. And third and finally, all right, and this one's a little bit more abstract to think about, but it goes back to what happens when we took the light bulb out, is that basically the circuit needs something to provide a load, or another way of saying that is just use the energy of the electrons. All right. So with that being said, for us, a basic circuit is as simple as saying something that is a battery, a couple wires, and a light bulb, or something that will use the energy of the electrons to get the electrons to move through it. All right. So with that being said, ladies and gentlemen, that is kind of our primer into how to make an electric circuit. Hopefully you've watched this video so that when you do the live lab tomorrow and we get a little more detailed, you'll know how to build a circuit and understand what I'm saying. All right. So that being said, that's the end of these notes, but feel free to go back into this construction kit and play around a little bit. Maybe put more light bulbs in here, play with more batteries, see what happens. See how many different ways you can accidentally set the batteries on fire. All right. So with that being said, that's where we're going to stop for this particular video, ladies and gentlemen. So with that being said, have a great rest of the day.